Alright, we started the recorder a little bit late, so you missed part of the lecture. Go ahead and just look at the code in the notes. I hope it's self-explanatory. We're talking about print statements. What we haven't been exposed to before is the idea of formatted print statements. Yeah, let's try it like that. We're going to do it new style. There was Python 2's way and then Python 3 way. We're going to put that in, that, and an end quote, and then instead of a comma, this is where it gets different. Like I said, it looks a little bit silly. Dot format x comma x to the power of 2, x to the power of 3, x to the power of 4. Now, since we had a parentheses here as well as here, we have to have two closing parentheses. Okay, now that didn't line them up, but it did show that we're printing four. These are called placeholders. That's a placeholder, that's a placeholder, that's a placeholder, and that's a placeholder. And if we want, we can specify how many characters we want, how many columns we want that placeholder to be. You know, X just goes from 0 to 49, so it's never going to be more than... Do we want them all just the same width? Let's try that. Let's do bracket 10, bracket 10, bracket 10, bracket 10. It blew up. Alrighty. Let me go back and refresh myself. Something. I should have just done it the old Python 2 way because I wouldn't be fumbling as I am now. Here I just want to show you. Okay, there we got it. There we got it. There we got it. See how they lined up all nicely? That colon inside the placeholder said give this 10 spaces. And so now, you know, if I change that one to 3, that first column would only have 3 spaces. If I want this one to be 5, that column would only have 5. That column would only have 7 columns available to it. By column, I mean spaces on the screen. And that one would have 9. And we did put spaces in between everything, too. You know, but I could delete those. I'm going to leave them there, though. And there we go. They are still lined up nicely, just not as blatantly as it was the time before because they were so spaced out so widely, but at least they're all still perfectly lined up in columns. So that's a formatted print. The way it works is you define your placeholders with the curly braces. Those are braces and not parentheses. If you want to specify the width, you put a colon followed by the width.
I feel like this is pretty advanced. Is this even the lesson for the day, or we just kind of...
We're going off topic, and then we're going to go back into the topic of lists. Okay, so I want you to have this tucked away because later on in other classes or whatever, you probably will be using the idea of formatted printing a lot, because anytime you want to print things in tables, yeah, you need the ability to do this. This will be the last example, though. I'm going to show you one more thing. Okay, so when we do this, let's change this format string. The format string is the first thing that appears. I love to read, curly brace in curly brace, curly brace in curly brace, and then maybe an exclamation point. Kind of like playing Mad Libs, right? When you were a kid and it would ask for an adverb and you'd write an adverb in there, you know, and it asked for the name of an animal, and these will be filled in with these. And if we wanted the word Harry to occupy 10 spaces on the screen, then we would put a :10 there. If we wanted Potter to occupy 20 spaces on the screen for whatever reason, we'd put a :20 there. Now, something that Python lets you do that some other languages don't is to rearrange the order as you're printing them out. Let me eyeball this real quick, make sure I don't make a mistake. Yeah. Okay. So I'm going to copy this, and I'm going to paste it. And what we're going to do here is we're going to put a 2 there and a 1 there. Now that doesn't mean 2 spaces because it's not being preceded by a colon. It doesn't come after a colon. Yeah, I wondered about that. Is it supposed to be 1 and 0? The example showed it as 2 and 1, but I didn't think that was correct. Alright, so look what it printed. I love to read Potter Harry. What happened is we have effectively a list of data here, and we're saying, well, I want element 0, and 0 is the first in the list, just like we had homework assignment 0, to go there, and I want element 1 to go there. And if we had more than 2 things in here, then we could keep adding, you know, we could print them out, we could add them anywhere we wanted to. So when we were doing our multiplication table up here, we could change that print statement to something that maybe looks better to you, maybe it looks worse. It's okay if you decide you don't like the way that this code is shaping up. Print placeholder times placeholder equals placeholder, and then end our quote. Nope. And then use dot format. And what are we formatting? We're formatting x, comma, y, comma, x times y. I'm going to modify this one so that it would produce the exact same output as the one beneath it. And just let you eyeball it and say which one you like better. That's shorter. But is this clearer? It is to me, may not be to you.
I like it.
Of course, I wouldn't leave them both there. Right, I'd just pick one or the other. Yeah, so we're getting duplicate, you know, prints because I had both of them there. But, okay. So now you have 2 tactics to approach the printing, right? Of the printing of the multiplication table. Do it one or the other way. Does that make sense, or? If anybody has syntax errors that they wish would go away, and it's okay if you can type this stuff in. I'm not going to post it in the notes.
running it?
Oh, I thought I saw.
No, no.
No, I was wrong.
I'm just typing it down so I've got it to right.
All right, so that's formatted print. The way the formatted print works is you use the placeholders. After the quote, you don't put a comma. Instead, you put dot format, and everything that you want to fill in the placeholders goes as an argument to the dot format function.
Can you run it again?
So here's my little silly multiplication table. Well, no, I think I went too far. Let me close it and run it once more. Alrighty, so up at the top it should be doing its I love rock and roll and I like hip hop. Then it's doing its multiplication, its weird multiplication table, which is not our answer at all. That's not what we wanted at all. I changed those numbers in the range statement. If I want to go back to the way that I really wanted it for the homework, I would just make that a 1 and a 4, counting by ones. And I would make the second one a 1. No, wait, it was supposed to count up to 10, so I'd make that 11. And then this one was supposed to go from 1 to 3, so I'm going to make that 1 to 4 by ones. All right, so that's the solution for that part of the homework assignment. That and that. All righty, shall we move on, or are people interested in typing and correcting syntax errors? Tell me to stop if you want to hang out on this for a minute more.
When we turn in the tutorial, do you want us to turn in this as well?
Oh, sure. I mean, if you want, I'd put it there just so that you have it, available to you. Okay, so speaking of books, what if we want a list of books? We need some light summer reading. Books equals, and then inside of some square brackets, I can't decide whether to call them brackets or braces. Let's call them brackets. And let's put some book titles here. What are my favorite books? I like Jaws. I like Hunger Games. Twilight is awfully good, so end quote, comma, I'm being silly. Twilight and Peter Cottontail. And I put more things than will fit on the page, so I'm going to change Peter Cottontail to something shorter.
Hobbit.
Yeah, The Hobbit. That's good. Hobbit. Now we want to print that list out. First, we're going to print it out the cheap, lazy way, which is going to print parentheses books. We should probably start this in a new .py file because every time we run it, it's going to be printing all these tables. But oh well. When we print it, it's not going to look too great, right? I mean, yeah, that's great and all, but a lot of languages won't even let you print a list with a single command like that. So we're taking advantage of something in Python there. Usually you have to use a loop. There are 4 items in our list. So here's what I'm going to do. For, and I'm going to use I as a counter, as my index. So that's an I, not a 1. For I in range, starting at 0, going up to but not including 4, stepping up by 1s, print, parentheses, books, and when I say subscript, I mean square brackets around it. Books, subscript, I. End brace, in bracket, end parentheses.
Did you mean to put a large space between the
Nah,
two?
not really.
Okay.
Why don't we just tidy that up a little? So now when I run it, it's going to print one book per line. It's going to print Jaws on one line. It's going to print Hunger Games on the next. It's going to print Twilight on the next, and then The Hobbit on the fourth line.
The 041, that's to indicate the number of columns, right? Or the number
Not
of
in this
books.
case. It's the number of books. Right. The number of lines, actually, we're printing in this case. And why did I start at 0?
Yeah, what's the
Because when we're accessing elements of the list, which is what we're doing here, we have to start counting at 0, not 1. You know, if we were people, we'd say, okay, that's book 1, that's book 2, that's book 3, and that's book 4. But as far as the computer is concerned, that's book 0, that's book 1, that's book 2, and that's book 3. So we set up our index to count from 0 to 3.
And what is the 0, what is 0, 4, and 1 mean again?
That's the starting of the range, and that's 1 past the end of the range. And this is how much to go up by each time. So what this is going to count is 0, 1, 2, and 3. There's a simpler syntax if you're going up by ones and you're starting at 0. For x in range 0, 5, going up by ones, that's going to count 0, 1, 2, 3, and 4. But you could simplify it just to look like this. For x in range 5, range parentheses 5, print x. And that's still going to print out 0, 1, 2, 3, and 4. So if the step is 1, you can leave it out. Well, why have I been putting it in? Because you're not always going up by 1s. Sometimes you're going up by, down by -1s or up by 10s or whatever. So I've been putting it there just to remind you initially that you can control the counter. But if you leave it out, it defaults to being 1. And if you leave out the first number, it defaults to starting at 0. Say I wanted to count from 15 to 25. Could I leave out the first number? No, because if I leave out the first number, it starts at 0. I don't want to start at 0. For x in range, so I want to start at 15. I want it to reach 25. But if I put 25, it's not going to get there. It's only going to get to 24. It stops when it hits that point. So I actually have to make it 26. But I can leave off the comma 1 if I want it to just go up by 1s. Put it there, leave it out. Makes no difference to me. Like that. And I'm going to rewrite this as a while loop to hopefully nail down why we use 26 there rather than 25. So I'm going to initialize my loop counter, loop control variable. Whoops, not to 0. We're doing 15 to 25 again. X is equal to 15 while x is less than 26, colon, parentheses x, and then x plus equals 1. These two things will do the same thing. That'll do the same thing as that. Why is that? Is it going to print out 26? No. When x finally reaches the value of 26, is it going to print anything? Is 26 less than 26? That's not true. So it would stop. It's going to go up to but not including 26. That's what this means. Start at 15 and go up to but not including 26. So loops and lists go hand in hand. If you have a list of data, you're going to want to be able to step through and do stuff to each piece of data you have. Otherwise, why did you save the list to begin with? So I'm going to make another list. Musicians' names, MN, is equal to square brace, Drake, the Beatles, Tool, and John Denver. We're going to just cover, make everybody happy or unhappy, depending. Okay, there we go. Now we want to print out all those elements. We're going to use a for loop. What index number will Drake be?
0.
It'll be 0, so that'll be 1, that'll be 2, that'll be 3. Maybe we won't use a for loop. Maybe we'll just print them out like that. Print, parentheses, MN subscript 0, into parentheses. And then just copy and paste that so that you're also printing out items 1, 2, and 3.
I feel like there'd be an easier way to do it though, right?
A loop is the right way to do it. Yeah. So really this should be a loop, just like we did when we printed the books. For I in range, there's 4 books, so I'm going to put I in range 4, parentheses, taking advantage of the fact that it'll start counting at 0 and go up by 1s if I don't fill in those values. Print, parentheses, musician name MN, subscript I, in subscript in parentheses. That'll do the same thing. So as a side point, if you don't know how long your list is going to be, you wouldn't want to hard code a 4 in there, because that would only print out the first 4 values. You know, you may have 1,000 musicians in your library, not just 4. So this should really be some way of calculating the length of the list. And fortunately, there is such a way. However, there's also a variation of the for loop. Excuse me. Where you don't need an index counter at all. You don't need to know how many items there are, and it looks like this. And I'm going to use V. My little internal nomenclature is that I is an index counter, but V stands for value. So for V in books, colon, print V. That's going to print all 4 of our books. For V in musician name, MN colon, print V. And that's going to print each musician. That's a cleaner syntax, right? That's a lot prettier than having to do an index like that. And in this case, it doesn't care about the upper range, so we don't have to worry about whether we had 4 books or calculating the length of the list. Not that calculating the length of the list is hard in this language. Guess I haven't run it recently to make sure I don't have syntax errors. All right. So what if we want to add up a series of test scores to calculate the average? Tests is equal to, and inside our square brackets, we're just going to put some test scores. 100, 90, 80, 40, 50. Now let's calculate the average. Now let's calculate the total first. Total is equal to sum parentheses tests. Sum is a built-in function that accepts a list as its argument. Adds up all the numbers. Of course, they better be numbers. If we did sum of books, it would blow up. And then how do you calculate the average? Sum divided by the number of items in the list. So average is equal to total divided by LEN of tests. How many items are in the list? That's what LEN tells you. And notice that it's a colorizing. the word sum there and len there to show that they are functions.
What is len again? Let me make a comment there.
Yeah, let's do that.
The sum of them.
Number of items. len equals number of length of list is what it means. So in this case, since we have 5 test scores, len would be 5. So let's print our test scores out, print tests, and then let's print the total. And we're going to do it using that newfangled funky formatting syntax. Print total equals, and then a pair of curly braces, and maybe some spaces, average equals, and then another pair of curly braces. Then we're going to do that end quote dot format business. End quote dot format, and we're printing out 2 things, 2 variables. Fill in that placeholder and that placeholder, and well, our 2 variables are total and average. So total comma average. All right, and there's my test scores, and there's my total and my average. Why don't we put something in front of the word tests so that at least we know what we're saying? How about on that print line we do test scores, end quote, comma, tests, just so that we know what we're saying. Now I'm calling them lists because that's what they are. The book's going to call them arrays. The problem is that Python doesn't strictly support arrays. Lists are more flexible than arrays. An array is like a list except it's fixed in length. I could start adding test scores and subtracting test scores. I could add new books to my list and subtract books or wipe out the list, But if it was made as an array, once you declare your book length, your book list to be 4 items long, that's all it's ever going to be unless you go and change the code. So when you're reading the textbook, everywhere you see the word array, think list. And whenever I say list up here, think array. And it'll all go well, and then you'll go to another language such as Java where you actually have 2 different things. You have arrays and you have lists, and then we have to keep track of the separate concepts. But for now, it's okay to think of them as being synonymous. Just like to a kid, a Persian cat and a Siamese cat, they're both cats, they're both kitties. That's good enough. But then when you're a vet, you probably want to know the difference because Siamese have hereditary diseases, Persians don't, or something like that, right? Alrighty, any typo helping we need? Are we all good?
Probably so. Just give me 1 second to double check.
Okay. Alright, for those watching at home, one of the things that I did at a certain point is I came up here and I put asterisks in front of all my books' names just to distinguish them so that when I ran it, we could see when we were printing books and when we were printing musicians. So, you don't have to do that. Okay, so we have this cute way of calculating the average, but it requires us to do, 2 functions. We have to call sum of tests and length of tests. We could do it like this, and don't type this because I'm going to delete it. We could do that the average is equal to the sum of the tests divided by the length of the tests. That's all well and good. But we're going to write a function that'll do that instead, because the way I would like it to work is I just want to be able to do this. Average is equal to AVG, and then give it the list name. Right. That'd be cool. So how do we define a module, a function? Those terms are synonymous as far as this class is concerned. DEF, AVG, and I'm just going to use capital L to mean lists. I'm not going to type test there because we might have lists of other numbers besides test scores. So that's kind of a generic variable name. And so then I'm going to do result is equal to the sum of that list divided by the length of that list. And then I'm going to return that result. Now that's my module. So if I want to calculate the average of our tests, I would just do this. Average is equal to AVG tests, because that's the name of our list. And we're filling in a hole in the Python library, which doesn't have an average command, although they have a sum and they have other ones too, like min and max. We want to find out what the minimum test score is and the max test score. We can do that. I haven't been typing in many notes. I've been typing it all straight into the code. Built-in list functions. I had a book that called them BIFs, which I thought was really annoying. BIF for built-in function. Alrighty. So anyways, there's length. That's kind of like the most important one. Then there's sum, and then there's min, and then there's max. Minimum searches a list for the smallest value. Max searches the list for the largest value. So let's print out the low test score and the high test score. Print low test score colon end quote comma. Now I'm going to use that dot format just to be annoying. Low test score equals curly brace, end quote, dot format, and here's, I'm going to need two parentheses at the end. Why two? Because, no, I don't need two. Yeah, I do, because we have one there, and one there, and one there, and one there. And the thing inside the printing is going to be min of tests, like that. All right, that's almost too many nested parentheses there. We've got 3 closing parentheses there. Then I'm just going to copy that and change low to high and min to max. So I copied it, I pasted it. I'm going to change the word low to high and the word min to max. Alright, and so the low test score was a 40 and the high test score was 100.
We're at the longest time.
Okay, so the reason we veered off and started talking about lists is because lists and loops go hand in hand. Lists are one of the best uses for a loop. Loops are absolutely essential for programming, for accessing lists. So, to go back to my notes over here, how to define a list. It's like this. List name is equal to, and inside of the brackets, you put value 1, value 2, value 3, dot, dot, dot. Everything is just separated by comments, commas, etc., comma, etc., comma, etc., like that. If there are names, you better put quotes around them. Names is equal to Joe, Bob, and Sam. If they're numbers, scores is equal to, you don't put quotes around them. 190, 80, and then he turned things around and went back to 100. There we go. And just as a reminder, just because you didn't make 100 or whatever on a homework, you can always revise and resubmit it, unless the reason you got a low score is because you were cheating. And I would certainly tell you if that was the case. Okay, so there we go.
Where you send link files instead of text files.
The link files, that's right, that's right. Yeah, I need to mention that. There are things that you want to make sure you don't upload. And one is, if you make a Word document, don't upload the temporary file. The temporary file, I've gotten a bunch of these
I
last
saved
semester,
it to my
not in this
desktop
one.
For a quick link, just
Uh-huh.
drag it over and didn't even realize.
Yeah, so here I've got a file going on. It's not going to let me get to the desktop easy. Oh, it's right there. Okay. And then as I keep changing it, maybe we can see it, maybe we can't, but at a certain point it'll come up with a file name that begins with a tilde. And that means a temporary file that Word has created that's not the proper file. And if you upload the temporary file that begins with a tilde or a pair of tildes, what's the tilde? It's this symbol. So don't upload those files, the ones with the tildes in it. And the other thing that you could accidentally do is if you drag something to the desktop, it may not do a copy, it may make a link.
That's what I did.
Right, so if you copy, well, I'm not going
They
to
came
duplicate.
from the linked, or the Lucid Art.
Yeah.
From the flowchart is when it really got me.
Yeah, and so when you're uploading your file, make sure that it doesn't have the extension .lnk. If you're uploading something that says .lnk, that's not the original file, and you just need to go and find the original file, and then you'll get credit for it after that.
Link for your computer, but you have no way of accessing it.
Right,
on your
exactly. Yeah, that link works great on your computer. You can double click on it and it'll take you there, but it doesn't work for me.
Gotcha. I mean, I knew that. I just
Yeah,
wasn't
yeah,
even thinking.
right.
Oh, okay, I'll just make it, put it on my desktop and send it to you. They all should be there now. I sent you a picture, a JPEG
Oh yeah,
file. Is that okay?
sure, sure.
It was on one of
JPEGs
the
are cool.
flowcharts.
Yeah, when you're uploading a flowchart, it doesn't really matter if you save it as a PNG or a JPEG or, you know,
Okay. As long as it doesn't say LNK.
yeah. All right, so back to our idea of loops. Nested loops never overlap, meaning that the inside loop always has to finish before the outside loop clicks one, just like minutes counting on a clock. If we were going to make a nested loop that counted off every 15 minutes of the day, we could do that. Let's say we're on military time and the hours go from 0 to 23. And so we want our output to look like this. You know, 0:00, I assume that's midnight, and then 0:15, 0:30, 0:45, and then we want to go to 1 o'clock, 1:15, 1:30, 1:45, 2 o'clock, and so on, all the way up to 11:45 or 23:45. Let's make a loop that does that. Well, we're going to need a nested loop because the inner loop is going to be counting the minutes, and it's going to be going starting at 0 and going up. Its step will be by 15. So that's what our inner loop's going to be looking like. For minutes in range. We do want to start at 0. We want it to get up to 45. So what am I going to put here?
46.
Exactly, 46, and I want it to increase by 15 each time. That's my inner loop, so I'm going to wind up tabbing that over. My outer loop's going to start at 0 and needs to stop at 23, so I'm going to make the range up to 24.
So the outer one's the right side.
Right. So for hours in range, I could just do that because it's starting at 0.
Yeah.
And it's going up by 1. But just for completeness sake, I'm going to put 0, 24, 1. Absolutely nothing wrong with giving it more information. All right, and then now when I print it out, this is not going to look totally good because it's only going to print out one space if it's a 0 rather than 2 zeros, but we'll deal with that. Placeholder, colon, placeholder, end quote, comma, nope, not when you're using formatted print, end quote, dot format, hour, comma, minutes. And I think at one point I've said hour, and then another point I've said hours. So when I actually try to get this to work, I probably have syntax errors because I made some of my nouns plural and some of them not. I'm going to go ahead and paste that into the code. All right, so there's my code for printing out all the hours every 15 minutes. All right, and you see what I mean? It doesn't look so hot. What do I mean by that? It says 10:0. And what do we like to see when we see minutes?
0, 0.
Both digits.
We like to see both digits. Python format leading zeros. That's what those are called, leading zeros. Oh, but I don't want to do it with the percent sign. Not finding it yet. I'm gonna zero colon 05D. Okay, this is gonna look weird. But remember when I did percent, or excuse me, colon 2 and it forced it to be 2 wide? That's a start, but it's not a total fix. At least it saved 2 spaces for the minutes, but it didn't put the extra 0 in. But we're getting there. What I need to do now is after the colon, I'm going to put a 0 indicating that all the extra spaces should be filled with zeros. So that's how I modified my print statement. Now that's almost looking like gobbledygook. I'm sorry about that. But that right there is a format specifier for printing out something that's 2 numbers long with leading zeros if need be. And now we have our pretty output.
EOF while parsing?
EOF while parsing. I have no idea why you're getting that. Let me come look. Yeah. Okay, so just to be silly, yeah, I'm going to put a 9 in there. And then when I run it, I will see the minutes formatted absurdly. But we can see. 9 digits wide, padded out to the left with zeros. And that's silly, so I'm going to change that back to 2. Why don't we do a break and come back at 120? Okay. So common loop mistakes. Failing to initialize the loop control variable. That really only happens if we're using a while loop rather than using a for loop. Because when we use a for loop, the variable gets initialized right away. But if I was going to rewrite this code to use a while loop, it would look like this, except I'm going to use H for hours because I'm lazy. H is 0 while H is less than 24 colon. M for minutes is 0. No, I don't need to put that colon there, my mistake. M equals 0, and then while M less than 46 colon print H comma M. I'm not going to take the time to format it nicely. Now in my inner loop I need to add one to M, and then in the outer loop I need to add one to H. So before I stop indenting,
Now, quick question: would H be considered global?
according to the book, yeah. According to Python, kind of dump the idea of a global variable for this language, because in this language everything's that you define is a global variable unless you put it inside, unless it's tabbed over. But all of your code is global in this language until you start tabbing over. I don't know if I'm giving you the only time the term global variable the only time you'd ever even bother thinking about global variables in Python is if you've written a function, like we did here, that needs to use a variable that's defined outside it. And then all of a sudden it matters very much that whether it's a local variable or a global variable. This is a local variable because it's defined within a module. And that's great. But if this function also needed to use a global variable, one that was defined outside it, then we need to start worrying about the syntax to do that. Global variables, the nomenclature becomes very important for the vast majority of languages, because in the vast majority of languages and I'm going to go off the map here, this is not Python. The vast majority of languages you have to define a main function or a main method. And if we were declaring a main method in Python, it would look like this. And then we'd have all of our code. Don't type any of this. X is equal to input, Y is equal to input, and Z is equal to X times Y, and then do some stuff. And then if you wanted to define any functions, you could do that. Print output X, and what's X that going to do? It's going to print X equals comma X. Okay. So, in some languages, all your code has to go into functions. You can't have any unindented code in those languages. You can't have any code that's outside of a module. But sometimes you can have variables that are defined outside of modules. The C and the C++ languages support that. So if you wanted to, you could set, a variable out here, and because it's defined outside of any modules, that makes it a global variable. But if I wanted to be able to change the value of that, I would have to do this, global name. That's just telling it that name is a global variable, and then I could change it to something else. Change it from Joe to Bob. And so then down in here, when I called that module, change name, it would run that line, it'd run that line, it'd run that line, it would pop down to here, which says, oh, I need to run that module, and the first thing it sees is, oh, by the way, I'm going to be using a variable called name, but it's a global variable. And so it knows to look outside all of the functions in order to define that variable so that when it was done, it could be changed to Bob. Otherwise, it's just going to create a brand new variable called Bob. So in those languages, the languages where everything has to be defined in a function, the idea of global variables is very important. And the idea of global variables still applies to Python, but only if you want to define a variable outside of a function of a module and then be able to access it inside the module. Is that making sense? Okay. Typically you do that if you have a variable that's going to be used in more than one function. And global variables are actually considered poor programming practice. They're considered kind of uncouth. There should be another way to solve the problem. We could pass this name into these functions, for example. But if we have some data that we want shared between multiple functions, between multiple modules, then global variables is a way to do that. You can simulate the fact that those languages require everything to be in a main module. In Python, by putting everything in the main module and then just having a line at the very bottom, the first unindented line of code is that. And so when it gets down to the bottom, then it would go ahead and start running main. And in my scripting class, I actually have people do that. I have people put all their code in a main module just because it looks more like other programming languages. There's another reason as well. Maybe I should in here as well, but nah. If you were going to flowchart this would be pretty stupid because you'd have a start circle and then you'd have a box of bars that said main, and then you'd have a stop circle, because that's all this is, right? We only have one line of unindented code. Then we'd have to go and define a main function and a change name function and an out name function. We ought to loop back and do some flowcharts like that, but I want to keep on the topic of loops. Back to the example where we're retyping hours and minutes. Okay, that we actually did that in. Okay. So if I had a function, if I did some DEF, and I'm going to delete this so don't bother typing it, h is equal to h times 3, yeah, we would need to decide whether we want to treat this h as a global variable or not. And if we did, we would tack this word onto it, global h. That would say, oh, by the way, this test function is using something that's declared outside it. Other languages have a similar idea. They might use the word extern. C and C++ do. This isn't C or C++. Okay. So that is our loop that does about the same thing, although it doesn't do it as pretty, right? Because it's not a formatted print, so the numbers come out looking, well, what do you know? What did I forget to do?
You got to have an input made for it.
I forgot to increment them.
Yeah.
So after the print, we need to add 1 to m plus equals 1. And then after the end while, I need to increment h plus equals 1. Like that. Now that'll work. And there it's going. I think it's working. Well, I made a boo-boo. What was my mistake? Why does this not exactly duplicate this one? This one was printing every 15 minutes, but this one's printing every single minute.
You didn't have it m plus equals 15.
Right, this line needs to be m plus equals 15 to go every 15 minutes. All right, now the functionality is equivalent, it just isn't as pretty of output. If I copied this format and pasted it here and put in h and m's, you know, great, it looked fine. But what if I didn't initialize h? That's what the textbook was saying. That's a common programming problem, and it is. I'm going to delete this line, but don't, because it crashes the program if I do it that way. It blows up because h is undefined. We can't check to see if h is less than 24 if h never existed to begin with. So, you know, dummy programming tricks number 1, failing to initialize your variables. Dummy programming tricks number 2, which I do all the time, forgetting to increment inside of a while loop. What would happen if I put this h plus equal 1 inside the loop by indenting it? Which is really easy to do when you're typing along with me or whatever. If you don't get the indentation levels exactly right, what's this going to do?
Crash?
Well, it's not going to crash, but it's not, the output's not going to be very pretty. Zero, 115, 230, 345, 4, 515, 630, 745, 8, 9. You see what it's doing? It's adding 1 to the hour every single time that it updates the minutes. And the reason it's adding something to the hour every time it adds something to the minutes is that's exactly what we told it to do. We said, okay, we didn't untab this. You got to untab that to take it out of the loop.
To give it its own.
Right, right, so that it happens only after all the minutes have counted down. Now that's the nice thing about for loops, is you don't have to worry about, you know, the incrementing is handled as part of the syntax. We didn't have to Look how much, even if I took these word end whiles out, you can see that it's a lot more, and pretend that my print statement was as easy as the other print statement. Print, hour, comma, minutes, like that. Right. Maybe this looks more complicated because the lines are longer, but structurally, this one's more complicated, right? We have several more lines of code, twice as many lines of code. We have to worry about where our increments happen, how far the increments are indented, and stuff like that. We have to worry about initializing that, and in a for loop, we don't. So that's kind of the advantage of for loops, is the syntax is very concise. You specify the start, you specify the end, you specify the increment, and you're good to go. All right, I'm going to undo that last change because I broke the code there. Okay.
So the one up above is the for loop.
Right. Guess I'll copy this and paste this into my notes. So doing the hours and minutes as while loops, as nested while loops. It's already in your code. If you're typing in notes as well, you don't need to create everything like I do, unless you just want to. Okay. So common errors. Forgetting to initialize your loop control variable. Forgetting to increment your loop control variable. And I'm sure the book's not going to say it, but you got to make sure that your increments are tabbed over to the right place, right? You don't want all of your increments being done inside the while loop. Inside the innermost while loop.
I was gone for a second. What's LCV mean?
Loop control variable.
Gotcha.
Yeah, so that's the second mistake. They say neglecting to alter the loop control variable. I guess that's a better way of saying it than what I did. Increment. Forgetting to alter your loop control variable. Example, not incrementing it. If you forget to alter your loop control variable, it'll just run forever. And we saw that when I ran the code, but I'd forgotten to add to the hours and the minutes. Just print it out 0:00 over and over and over. Mistake, using the wrong comparison when testing loop control variables. You must use the correct comparison. Yeah, that sounds right. The seriousness depends on the actions. You could overcharge the insurance customer by 1 month. You could overbook a flight on an airline application. You could dispense extra meds. Woohoo! Alrighty. Including statements inside the loop that belong outside the loop. Well, what if we had this? We were trying to calculate the sum of all the numbers between 1 and 20, and we wanted a function that would do it. I could write a function called summation that would do that. I guess I'll do it in idle. Define summation. And I'm going to start our counter off at 1, and I'm going to end it at 20, so I'm going to make it less than 21. X is equal to 1, while X is less than 21. And under normal circumstances, I'd make it X less than or equal to 20. But I've been going with less than because that matches the idea of the for loop exactly. So anyways.
Give me the definition of the program you're running right now, or what you're actually doing.
What we're writing here is summation, which is going to add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on.
So just 1 plus 2 plus 3 all the way up to 20.
Right. And there's a mathematical symbol for it. I'm probably not going to be able to find it. There it is. Yeah, that symbol. If you ever took a math course that does this, add up all the numbers between 1 and n in this case. But we're going to do 1 to 20. So we're going to start our loop off at 1. We're going to stop at 20. We need a variable to hold our total. So total equals 0. So inside the loop, we want to add x to our total. Total equals total plus 1. And then we better increment x. I'm not going to forget to do that this time. X plus equals 1. And now let's print out our total. This is not the right place to put the printing of the total out. If I add the end while comment, it'd be blatantly clear why that's the wrong place. Well, I've written this as a function, so if I want to actually trigger it, I need to make a... I've written it as a module, so I better invoke the module. I better call the module. So down here, underneath it, unindented, I'm going to do that. So what's the problem? It's not going to print the A total. It's not going to print D total. It's going to print out 20 different totals. As a matter of fact, I can't say that I think that it printed out anything I wanted at all. Let me go back and look at my code. Oh, not total is equal to total plus 1. What should that be? If I'm adding 1, 2, 3, 4, and 5, that needs to be my loop control variable. My mistake, I didn't mean that wasn't an intentional error. Total equals total plus x. Alright, so we run it and check it out. It's printing out all of the totals, all the interim totals as well as the final total. I probably only want this answer. I probably only wanted to say 210. So what should I have done? What did I do wrong? I didn't want it to print out all the interim totals. I only wanted to print it once. The problem is that it's printing it inside the while loop. And so if the while loop repeats 20 times, we're going to get 20 different totals. If we were adding up all the numbers between 1 and 1,000, it'd print 1,000 totals. That's not cool. So what do we need to do to fix it?
Change the x plus 1 equals 1.
The incrementing of x is okay. The problem is that since print is inside the while loop, it's going to print every time x changes. So if x is going up to 1,000, it's going to print 1,000 different totals. So what do we need to do? We need to take print out of the while loop. And how do we do that? Yeah, I just changed the indentation. You know, if I back it up like that, then it's no longer part of the while loop. Now, if I was intent on keeping my structure here with my end while, I would cut that comment and I would paste it above that. So just make sure that stuff that is inside the loop needs to be inside the loop, and that things that should be done at the end of the loop are not inside the loop. When this print statement was inside the loop, it was a problem. Now, the languages that use the curly braces to indicate code blocks make those a little bit easier to figure out. Let me, I probably undid too many things. But if the code had looked like this, it might have been real easy to see what it was going to do, right? It was going to print the total every single time, rather than waiting until the end of the while loop. But this language doesn't support that brace nomenclature. That's Java and C style. Instead, you do everything with indenting, and it's easy to make a mistake eyeballing the indentation levels. Okay. That's my final answer.
Do you
That's-
still need summation at the bottom?
I do. Otherwise, it's not going to ever call it. We've defined it without using it, unless we put that there. Very good point. Guess I didn't test it. Let's run it. Ooh, need a colon there. If you don't have a colon at the end of your while loop, You better put one. I sure didn't. And I closed my code to make things worse. Come back. All right. While x is less than 21 colon.
20.
All right, if I was going to write this in a cleaner syntax with a for loop, it would look like this. Total equals 0, and then for x in range, take out the parentheses that I typed and put it here instead, starting at 1, going up to but not including 21, increasing by 1 each time, total plus equals x, or total equals total plus x. Either syntax is fine. And then underneath here we could print out the total. Even if I added that comment, you can probably see that using a for loop makes the syntax more concise.
This is for.
I'll bring the code back in a minute. So our common errors: forgetting to initialize our loop control variable, forgetting to alter it, putting something in the loop that should happen after it. And so that's our example, is this is wrong. And moving that print statement underneath the end while is correct.
Can you go back to that for loop? Total equals 0.
Sure, sorry about that. I spaced out a second. There we go.
What did I do wrong?
So as I mentioned before, if you leave off the comma 1, it assumes that it's going to be adding 1 to it each time. So technically I didn't have to put that. But I like seeing all three of those numbers there. You'll see this syntax echoed in other programming languages. In Java or C, this for loop, and you certainly don't have to type this. Maybe I'll just put it as a comment underneath here. It would look like this. For x equals 1, x is less than 21, x plus equals 1. Same thing, right? We see the commonality here. This is a C style, C Java style. It works like that, but you can see that it's starting, it's initializing the loop control variable, it's testing it each time, and it's altering it there at the end. Same syntax. And in this language, you don't have the option of leaving off the last thing, and having it automatically go up by 1. So I'm just pleased as punch to go ahead and specify all three things: the beginning, the end, and the step. Move this over to our notes. So using a for loop, a definite loop provides three actions in one structure, in one statement: the initializing and the test and the alter. Here they're showing pseudocode for a for loop, which looks kind of like that C version I was doing. For count equals 0, 2, 3, step 1. Now, I'm not going to concentrate on how to do a for loop in pseudocode. Why learn a new syntax? But that's how they want us to do a for loop in pseudocode. If we were going to do it that way, it would look like this. For, well, I've already forgotten. Let me look at it again. For variable equals something to something step. Okay, so for x equals 1 to 20, step 1. That's how they want us to do it in pseudocode. Meh. I'm pretty much at the point where I'm going to stop asking you to write pseudocode anyways. So I'm not absolutely 100% sure I'll never ask you to write anymore. So don't take that as, don't file a lawsuit if we have to do any more pseudocode. One reason I don't like this is because it's doing the 20 and this is doing the 21. This is actually the basic programming language syntax. Basic being invented in the late 60s, early 70s. It was originally intended as a educational programming language, but then it became shipped with all those early computers, those old Ataris and Apple IIs and things like that, and so millions of programs were written using BASIC. And same was true of the PC, and so Bill Gates invented Visual Basic, which would let you write Windows programs in BASIC, with Windows and everything. So it's still a very commonly used language. However, it's a lot more complicated than it was for the version that was invented in the 60s and the 70s. It looks a lot more like these other languages like C and Python and Java. So the step value is the amount by which a loop control variable changes each time. You can use a while statement in place of a for statement. I've been showing you that you can write something as a while and you can write something as a for. Can you always write things as a for if you wrote it in a while? No. But if it's a counter, yeah. Counters are great. For loops are great for counters, and for loops are great for stepping through lists. But there's lots of things that you can do with while loops that you can't do with a for loop. How would you write a for loop that asks the user for their guess and check to see if it was a certain number, if it matched the secret number? I can't think of a way to do that. That's a while situation. Keep running until the game is done. There's no for loop that'll figure out in advance, how many turns. Well, I guess you could do, for turn equals 1 to 10, but nah.
Too complicated.
Yeah. So then there's something called the post-test loop. I'm going to mention it. There may be a test question in your online test about post-test loops. I'm certainly not going to ask about it in my exam. But you'll want that point in the MindTap test. And please do those MindTap tests. I can guarantee that the people who take and retake those tests until they get 90% or above on them, because some of the questions on my exams are drawn from the MindTap. Anyways, what's post-test? When we had a pre-test loop, it meant that the comparison was done before it went in, like this. X is equal to 1, while X is less than or equal to 10, print X, and then do something, add 1 to it. That's a pre-test. Pre because it's testing it before it goes into the body of the loop. Python doesn't have a post-test loop, but if it did, it would look like this. Because the other languages that do have them, make them look like this. Do. Okay, well, we have to define our variable. X is equal to 1. Do this. Print X plus equals 1, and keep doing that while X is less than or equal to 10. That would be the syntax for a post-test loop. Why is it called post-test? The comparison happens at the end. It doesn't happen at the beginning. And quite often the results are the same, but there's a key difference. If I wrote this as my while loop, forgetting the do loop, how many times is X going to be printed out? Is X less than 10? Nope. So just like an if statement, it's not going to even do the body of the loop. It wouldn't print out a thing if x is equal to 1,000. Or if this test condition is false, it doesn't go into the body of the loop. Howsoever, if you have a do loop, even if the condition is invalid, right? X is equal to 1,000. Print X, it's going to print 1,000. And then it'll add 1 to it, and then it'll check, oh, was X less than 10? No, it wasn't, so it falls out of the loop.
So will it print what?
It'll print it one time. Right, it'll print 1,000.
Just
and
1,000?
It'll stop. Right. It would print 1,001 if we reverse the order of these.
Okay.
But we're printing it out before we update it. So that's the key difference between a pre-test and a post-test loop, is that a post-test loop, it will go into the body of the loop no matter what, whether the condition is true or false, because it'd be like if you were going to a club and there was somebody outside the club checking your ID, or if there was somebody in the club who checked your ID only after you got your drink. Here you get your drink. Here, your drink is dependent upon whether, you were the right age or not. Silly example, but okay. So that's a post-test loop. I'm going to change this back to 1, and I'll just make a little comment. A couple of comments. Python doesn't have post-test loops. Java, C, C++, JavaScript, all sorts of other languages do. Why? Because I guess the inventor of Python just didn't like them. So, and the key point is that with a pre-test loop, if the test condition is false, the body of the loop is never entered. With a post-test loop, the body of the loop is entered no matter what. And then the test condition is evaluated. Wrong. Right. So I never flowcharted do loops. I guess if we were going to, let me think about how I would do it. Here's what our while loop looked like. We had, some statement here, and then while. Well, let's just do the same example that I had in our code. Everything begins with a start, and then we had x equals 1. That's math. I'm not putting in a block with bars because we're not calling a module. We're just doing math. So x equals 1. That's our block, our process. Now we're going to enter our while loop. The book wouldn't show the word while. It leaves that out, but I like it. While x is less than or equal to 10. If that's true, we're going to print x out. Prints are done in that. Everybody knows that. I'm happy for y'all all getting that right in the exam. If the print or output x, add 1 to x. And then it's time for our loopy-looping. So we would draw a line like that. The textbook would have us draw the line going straight over here. Right? They wouldn't have us doing it like that. They'd have us something like that. And then once the loop is done, we're all done. So that's a stop. That's a while loop.
you get that text box?
I grabbed it and dragged it. Click
Right
and
there.
drag. Yeah.
Yeah, on the, there was calculation of the pyramid or something like that. I just sent you 2 files because I didn't know how to get the text into.
Yeah, it's fine. I don't
Okay.
care if you put the code inside the... Alright, so the do loop is going to be similar. Let's start off with our start block. I'm just going to copy and paste. No, where did you go? I guess I'm not going to copy and paste. And then we set our x variable equal to 1. Not c is equal to 2, x is equal to 1. And then I guess I'm going to just put the word do here. I better go and look and see how they did it. Yeah, okay, and so then we would print out x. We would add 1 to x. I may even get rid of that. So x plus equals 1. Then we would have our step, because it's a post-test loop, while x is less than or equal to 10. And if that's true, come back up here and repeat. The reason I was thinking about adding a circle that said do is because I thought it might be nice just to see the word do. But on the other hand, we don't see the word else, so why should we get to see the word do? And then we come down here and we would stop. And if I hadn't made everything so big, if I'd squished things down, we could get these all, you know, on one page more easily. Forgetting the fact that they're not lined up nice. All right.
How are you zooming in?
Holding the control key and
Control
spinning the mouse
and
wheel.
the mouse. Okay.
Yep, yep. Okay.
Control spin.
Yep, control spin. All right. So, do you see why with a post-test loop it always does the body of the code no matter what the initial value is? Because we're just falling into the loop, right? We go in here and then we test it. Here, he's the gatekeeper. We don't do we do the test at the beginning rather than the end. And I am gonna drag the thing over there and put the word do in it. That's just kind of like a comment, but like that. I don't know. I guess I should just call it a pre-test or a post-test loop. Get rid of that word do. Okay. Ah. No more talking about it because it's not in our language. Just tuck it away in your brain for when you move on to other languages, as I hope you do. All structured loops have these characteristics. The loop controlling evaluation must provide either the entry or the exit from the structure. And the loop controlling evaluation provides the only entry to or exit from the structure. Some languages support a do until loop. Keep running until x is equal to 10. Which is a post-test loop, you know, and yeah. I've never used a language that has that, or at least I don't remember. But it would look like this. Do some stuff. Until x equals 10. Kind of neat. I don't know why more languages don't have that.
It's the double equal sign.
Double equal is a comparison. Single equal is assigning. This
Okay.
sets x equal to 1. This
Okay.
compares it.
That says until x becomes 10.
Right. If I had that, then I could conceivably erase x and replace it with 10. Some languages would call that a syntax error. Others are just happy to let you do it. The C programming language would go ahead and do it. It might give you a warning as you compiled it, but that's what the double equal means. So common loop applications. You can use a loop to accumulate totals. We just did that with our summation. We had a loop, and each time we went in, we added something to it. An accumulator, the variable that gathers values, which is similar to a counter. Now we did both. We did it was counter-based, but it didn't have to be counter-based. You could ask them for a series of test scores, entering the test scores, and then add them up as you went along. Now when we are finally working with lists more comfortably, then that would be a better application. But, enter test score 1, and then we add it to the total. Enter test score 2. So like total is equal to 0. How many are we going to do? I don't know. Counter is equal to 1. While counter is less than or equal to 5, we're going to do 5 tests. We would input the total. Total is equal to input, and I'm not actually putting this in idle. Then we would, nope, that's not right. Score is equal to input. And then add that to our total, but we better convert it first. Score equals float score. And then add that to our total. Total plus equals the score. And then add 1 to our counter. That would add up a series of scores. If we wrote it as a for loop, the syntax would be a little bit shorter. Total is equal to 0. For counter in range 1, 6. We would get the score. Now I'm not telling them what to type, so they would be very confused when they ran the program. They wouldn't get any messages on the screen. It'd just be a blank screen. Bad programming. Score equals float score. Total plus equals score. Okay, so that's the same thing written as a for loop. This variable is called the accumulator. And this variable is called the accumulator. Same variable name, same purpose. I would use the word sum because it's shorter, but sum is that built-in function that we demonstrated earlier. So I'd steer away from using sum as a variable name in this language. Obviously a sum and a total are the same thing.
So the bottom there is the for loop.
Right, that's the for loop version. To make it totally correct, I would need a colon after the while statement, and I would need to tell the user what they're doing. I would need to put a print statement. Print enter score. And I would need that statement down here as well. Yeah. If I was doing pseudocode, I wouldn't have that print statement and I wouldn't have that float statement.
You put print on
Yes, just to tell the user that they need to type something in so that they don't have a blank screen in front of them with no useful help. Anybody need to see this a little bit longer?
the.
Okay. Oops.
So So the beginning value there was the accumulator.
Yeah. So when we're doing this kind of adding, accumulating requires three actions. You have to initialize your accumulator to 0. And then the accumulator is altered once per iteration. See, we added the score to the total. And then at the end of processing, the accumulators are output. I didn't do that. I skipped outputting a score. I could tack that on. Print total. Like that. And I'm going to copy and we can put that line under both of my loops. So 3 requirements for accumulators. 1, initialize the accumulator before the loop. Alter the accumulator in the loop. And then 3, output the accumulator after the loop. I wouldn't say output, but I would say use the value, right? I mean, you may not display it, but you wouldn't be calculating this if you weren't going to use it somehow. Maybe as input for another calculation. Like when we were calculating the average, we didn't have to display the sum in order to get the average. But that's what the textbook says, the 3 requirements. So I could gussy that up and say output or otherwise use the accumulator. Output/use, how about that? So a summary report contains the totals with no detailed data. You know, I could make a summary report of, you know, the students in this class, and I would put all the averages, but I wouldn't show each test score and each homework score and stuff like that. So the loops are processed, but the detail information is not printed. You can use a loop to validate data. Data validation, making sure that the input is correct. What if the user types in something stupid while they're typing in data? Are you going to allow that, or are you going to forbid that? If we were entering test scores, we might want to make it so that the program wouldn't allow any score past a certain value. What do I mean by that? If you're doing test grades between 1 and 100 or 0 and 100, you might not want to let them do negative numbers. You might not want to let them go more than the max. If you have extra credit, you know, whatever, but if otherwise the max would be 100. So if you're going to do some validation to make sure that the data falls in acceptable ranges, like if you're entering your birth date and, you know, you're supposed to enter it in the format of 2/3/2015, well, what if that 2 was a negative number? That's stupid. It shouldn't let you do that. What if the 2 was greater than 12? Well, there's no month greater than 12. So let's write a little loop that would check that. Data validation. Make sure a value is within the proper range. And when I say value, I should say input. Make sure input. So what we could do is say print enter the number of your birth month. A long way to say it, but anyways, we want a number. So what's our range? 1 to 12. So let's get our input. Month is equal to input, parentheses in parentheses. We better convert it. Months are whole numbers only, so I don't mind converting it to an int. Month is equal to int parentheses month. But we need to make sure that it's good data. While month is less than 1, because that's invalid, or month greater than 12, because that's also invalid. This is an error state. If they typed in a month that was less than 1 or greater than 12, we're in trouble. So we're going to print an error message. No, month must be between 1 and 12. And then we would ask them again. I think I'll just copy that line and that line and that line and paste them rather than type in those 3 lines again. Like that. Now I didn't put this into Python, but I think the syntax is correct. I think that would work.
Give me 1 second, I'll check it for you.
I'll move it over into idle as well. Let's,
Let me put the print month again at the bottom. Underneath the while month is less than 1 or month is greater than 12.
yeah. We ought to go ahead and print it out. Just to let them know. Your month equals, right. Something like that. That's cool. All right, I'm going to move that into idle.
Oh, so it's asking for it again if it's not within those parameters.
Exactly.
Got you.
But if it's correct, no problem. It won't do any of that stuff.
Okay, so no.
All right, I've got errors. When I wrote my summation as a for loop, I got the tabs messed up. Maybe only one of them. Grumble. Okay. Enter the number of your birth month. I was born in the month 13. No, you weren't. 0. Nuh-uh. 1. Okay, my month equals 1. So that's working. That's using a while loop for data validation. Notice that we had 2 places where the input is done. And that's not my favorite style of writing this, but it's the way that the book's always demonstrated. This is what's known as using a priming read. And I think I've already mentioned that. We get our first input, prime the pump. And then if we need to get additional input, that's inside of the loop. They type in an invalid month, then we have to ask for it again. But we don't know whether it's valid or not unless we did the priming read, the initial read to begin with. Now usually the term priming read or priming input is when you're like getting a series of values, a series of test scores, or you're opening a file and reading a series of things that you're going to calculate. But this is the same case actually, you know. It's just that we're hoping that they don't enter more than one piece of data. We're hoping they get it right the first time.
Ah, crap, I forgot I have that.
I was wanting to finish that previous one
Yeah.
before it started the next one. Okay.
Here, where I was having it add scores up, I don't even know where that was.
I've been taking notes in Python as well. Just to keep it.
Where'd I put it?
It's in Python last setting.
It's where you wrote accumulators.
Yeah.
You got commented accumulators.
There they are. Okay. We should make this look a little bit better by telling them which score number to enter. Right. Enter score number, end quote, comma. And if you didn't put this in Python, that's fine. Counter. That way at least you'd see that it said enter score 1, enter score 2, enter score 3, 4, and 5. So why don't you go ahead and make that change.
Okay, so while counter is less than 5.
And do that in the same for the for loop as well.
Enter score number,
Yep.
comma counter. And do the same on those.
On the for loop, right. That way when you run it, when it's asking for input, it'll make a little bit more sense. It won't just look like it's stopped. got stuck. And if you didn't put that code in idle, that's totally fine. So you can use it to validate data, make sure that the data falls in acceptable ranges. I don't know why we threw this in here, but GIGO stands for garbage in, garbage out. You've heard that phrase before. If you put bad data into the computer, you're going to get erroneous output, and that's you can try to capture it with data validation, with defensive programming. So, limiting a reprompting loop. Reprompting means asking a question over and over and over. Reprompting can be frustrating to a user if it continues indefinitely. Maintain a count of the number of reprompts. Forcing a data item means override incorrect data by setting the variable to a specific value. I guess that's saying that if the user just can't figure it out after they've made 5 mistakes or whatever, you just go on your merry way. Right? We're not going to concentrate on that.
That was a test question, by the way.
Okay, yeah.
That's
All right,
last
so
night about 4 o'clock.
So let's since it's a test question, let's focus in on it again. When might an example of limiting a reprompting loop might be? To me, it seems like if you're asking the user for something. Okay, in some of my classes, I have an assignment where we're calculating the density of a sphere. Did we do that one in here? Or you know, if you have
sphere, pyramid, volume.
What this one did is it said how big is the sphere and then what material it's made out of, like gold or aluminum or ice. And so we listed a set of materials. 1, ice, 2, gold, 3, aluminum, you know, and then the other ones. And what if they chose something wrong? What if they chose, 0, something that wasn't on the list? Then it could ask them again. But what if they were stubborn and they kept typing in 0 just because they were jerks? Eventually you might go, defaulting to water or defaulting to gold and then keep going that way. So that's forcing, you're overriding incorrect data by setting the variable to a specific value.
Can you set it to where the number of inputs that are wrong, like if you set it to where, okay, this guy is going to get 10 tries to get the correct answer.
Yeah, you could have some kind of counter.
Okay.
Yeah, you could have a counter where after a certain number of bad attempts, it just goes
I'm
on.
not going to waste any time. You get 1 try.
You get one try only. So validating data type. What if they type in something that's not even of the correct data type, meaning it wants a number and they type in a letter? Programming languages usually have a way of checking to see if something that they typed is, if data is a number or not. There will be functions like isNumeric. In Python it's called isDigit. IsChar, is it a character? In Python it's called alpha, isAlpha. Is whitespace or is upper. What does whitespace mean? That they've typed in a tab key or a space bar. And we know what is upper means. And then that way you could check to make sure that they gave us some good data. Why would we care? What if we asked them to enter, their age and then they type in a word and then it hits that float statement and it crashes? Let's see if we can figure out a way of fixing that. I don't necessarily want you to memorize every single step that we do here, but I want you to have the concept down of the data validation. I'm tired of waiting for all this stuff to finish each time we run it, so I'm going to stick it up at the very top. I'm going to do it up here instead. Age is equal to input. Please enter age.
Aren't you still gonna have to wait for it to stop just because it'll show everything and then you'll have to scroll back up? You know what I mean?
Well, what I mean by that is that every time I run this, I'm now having to do a lot of stuff, especially if you were putting those test score stuff. And so I'm putting this code up at the very top, just so that if I was going to test it, I'd see it first. All right, so age is equal to input, please enter age. And then we need to convert it to a number, a float or an int. All right, that's all well and good. print your age is, followed by the age variable, and then let's just stop for a moment. Hit enter to continue. Okay, so when I run this, it's going to work great if I give it good data. What if I give it bad data? What if I type in a word? What if I type in any new non-numeric data? It doesn't know what a 4% means. What if I type in 30? It certainly doesn't know what that means. And we don't want the program crashing. You know, for these little silly test programs that we write, yeah, it's okay. But, you know, if we were giving somebody production code, we would not want them to be able to break the program just because they typed in bad data. Instead, we would want to tell them that it's bad and keep going. There is a method, there is a function, a module called isDigit. And I actually have to Google it up, sorry. isDigit Python 3. Okay. Here's what we would do. We're going to put a data validation loop. So after we get the age, we would do if age.isDigit parentheses in parentheses. Except I'm going to change it to the word not. If not age is digit, colon, we would need to tell them what was wrong and then let them enter it again. Print numbers only, please. And then age is equal to input. Please enter age. So the not just reverses the truthiness. If it really is a digit, then that would return true. But we only want it to repeat if it's not true. Another way to word that, I don't really like using the word not, is I would do this. If age is digit equals false, and this language requires a capital F in there. So this is a Boolean value, false. This is a Boolean function, Boolean module that returns true or false. Okay, so we've done some data validation to make sure that we can't crash the program by entering bad data. If I type in 4%, it says numbers only. If I type in a word, oh, well, what do you know?
Time to turn off the computer, huh? Could you write a program that does that? That just kills the computer if you blow the program up like that?
The operating system's supposed to not let you kill the computer. The operating system tries very hard to make sure that your code can't do things like that. But there are always things at the command prompt. Restart. No, that's not it. Commands that you could enter to force a reboot of the computer or something like that. And if your program can execute those commands, then yeah. I don't see what's going wrong here. Why did it think that that stuff that I typed, DSF, SADF, oh, because I made it an if. It's not looping, right? So, if I change that to while, then my faith in the universe is restored. It's going to work now. Please enter age. All right. Eventually, I type in a good value.
Can you go back to
There we go. If we wanted to make this example really complex, then we could do that thing of where they only get 5 tries, and then if they continue to botch it, you know, we just go on with some default value. But nah, just get that question right on the MindTap test and go on from there.
Where are we at on those exactly? Because I remember doing 1 or 2 of them, and then have we just been like supposed to be doing them on our own, or?
Yeah, each time we finish a chapter, so you're going to want to catch up and get to. We've done enough of chapter 5 that you could do the chapter 5 MindTap. I'll post a notice to that effect at the end of class today, which we will be hitting pretty soon.
Okay.
So do you remember our inner test score code? It should be doing data validation to make sure that the user can't enter bad test scores. We should be putting this loop inside that other loop. We should have a nested loop. The inner loop makes sure that that single number that they typed in is a valid piece of data, and then the outer loop is the one that continues to average the test scores to add them all up.
Ooh.
More likely, I would make this a module that I could call so that I could get a number anytime and have the module take care, and then I could reuse it over and over and over with a single call. And that would look like this. Define, let's write something called define input num. And then take this code from here to here.
Hell.
Copy it. In fact, take all of this. All of those lines from age is equal to input to age is equal to float age. Copy that stuff. Come underneath your module definition, paste it, and then tab it all over. Increase everything's tab level by 1. Now we shouldn't use the word age every time, because this might be asking for something other than age. We might want to let them pass in a string that would specify what number. But for now, I'm just going to say, please enter number. Right, make it more generic. So I'm going to change those 2 words inside the prompts from age to number. And then when I wanted to do that, when I wanted to use it, it would look something like this. Print enter weight. And then W is equal to input num. Print enter height in inches. I is equal to, or inches is equal to input num. Something like that. We have encapsulated the complexity of doing this data validation into a single module, so that anytime we want a number, we can use that and it will do that data validation. It will make sure that they type in a number. And if we need to add some additional validation, like they're only allowed to type in positive numbers, it can't be a negative weight, no matter how much Kate Moss might want to be. So that's the idea of modularization. We've written a module which we can invoke over and over and over any place in the code to hide the complexity. I wouldn't want to have to stick this kind of loop every single time I wanted to ask for a number. But if I could write a function and then just copy that function into my code and invoke it whenever I need it, that would be cool. Or I can make a library that I could import, just like we've been importing the turtle library and stuff like that. This is dumb though, because I forgot to make input num return anything. So this code is actually invalid. I need a return age statement at the very bottom of input num for it to have done anything useful. Return age. And at this point, calling it age inside that loop is kind of dumb, right? Because it's really just asking for any number. So I apologize for making so many changes, but you see everywhere the word age appears inside our module. Just change that to NUM or something like that. There's like only 5 places where it occurs. It won't take us long to do that. Okay, 6, 7, 8, but whatever. There we go. And let's print that information out as well. Print, your weight is placeholder pounds, and your height is placeholder inches. I made that too long to fit on my screen. But it's not too much on your screen. Dot format, weight, comma, inches, in parentheses, in parentheses. I wonder if that'll actually work, if it'll accept that as syntax. And then I need another pause statement. Input, hit enter to continue. I'll bring the code back in just a second. All right. That is about enough for that chapter.